Hey everyone, so Mr. Lambert here with your daily bell ringers. We're going to run through these together. So today, our first bell ringer question. Make sure as we're working on these, you have a sheet of paper that you are using to follow along with us. You're working out your stuff on a piece of paper, and whenever you get the prompt over on the right-hand side, you're going to want to go ahead and type your answer in there. Remember to do your best work today because this is for a grade. All right, this is all review. So our first one here is use the greater than, less than, or equal to sign to solve the inequality below. So look at these two numbers. I'm not going to read them to you just yet. I'm going to have you read those, and then I will read them and work through the problem here with you in just a second. So go ahead and figure out which symbol on the right-hand side there to use. All right, let's try this one together. Go to our next slide here. All right, so I have 4 and 7/10. Is that less than, greater than, or equal to 4 and 7/100? Well, our first one here, let's go ahead and use our pen tool here. We're going to do red, so let's do 4 and 7/10. So let's do this guy in red. 4 and 7/10. Well, of course, there is an imaginary 0 after all of these numbers. So the one we are looking for that looks like 4 and 7/10 is going to be this guy right here. So we're going to place a little dot here. There is right about where 4 and 7/10 would be. Now, in blue, I'm going to do my 4 and 7/100. Now, this is 7/100. So this is going to fall, remember, there's an imaginary 0 out of each of these, so we need 4 with a 0. That would be 0.0. So it'll be somewhere around here. And 7/100. That's going to be, so this is 10/100. 1/10 is the same as 10/100. So this is going to be a little bit over halfway closer to this guy over here. And we know from ordering our numbers on a number line over the past week, we know that anything to the right is going to be larger on our number line. Even when we're talking about negative integers, to the right on our number line is always greater, to the left is always less than, unless we're talking about absolute value. But in this case, we just want to solve this inequality. So this guy over here, our 4 and 7/10, is going to be larger because it is further to the right on our number line. So our greedy duck, of course, is going to be wanting to chomp up the larger of the two numbers. So this should be the inequality. You use the one with the open part to the left. That is the greater than sign. So 4 and 7/10 is greater than 4 and 7/100. All right, let's move on to our next slide here. So Mike made a 9-inch sub sandwich. He needs that cut into 1/2 inch pieces. How many pieces will he be able to cut? So think this through. We have a 9-inch thing, and we need to cut it into pieces that are 1/2 inch piece long. How many pieces will he be able to cut? Go ahead and try this out on the piece of paper. Type your answer in on the right-hand side, and then we will check it together. All right, guys and gals. So let's go ahead and use my writing tool again. Let's do red because I think it's a little bit easier to see. All right, so we have a 9-inch sub. We could draw this out. It would be 9 inches long, right? So here's our 0 inches. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 0 all the way up to 9. All right, so here is our sandwich. Let's have an imaginary sandwich. It's going to be this long, and we need to cut this into 1/2 inch pieces. So if each of these are a full inch, I'm going to get my blue here, and I'm going to cut each full piece into 1/2 inch pieces. So I'm going to make a slice there, another slice, all the way down my sandwich until I get to 9. Now each little piece here, like when we're doing absolute value, each little piece is going to be one of the pieces that we made in our sandwich. Oops, I missed a piece over here. Whoop, there we go. So now we just need to count out how many pieces we've got. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 pieces. So we could do 18 pieces. There's another way you could have done this out. So we have our 9-inch sandwich, and we need 1/2 inch pieces. So that's 9. We're actually going to divide that, because we're taking our big number and we're going to divide it by pieces into pieces that are 1/2 of an inch big. That is a division problem. We can do that. And remember, we're dividing two fractions, so if we were to do this, we would keep our first number the same. We're going to do keep, change, flip, so we'll keep our 9 the same. We would change division to a multiplication symbol, and we would flip our second piece here from 1/2 to 2 over 1. And if we do that, ladies and gents, we get 18 over, because 9 times 2 is 18, multiply straight across. 1 times 1 is 1. We would also get 18 pieces here. P-I-E-C-E-S. There we go. 18 pieces would be your total. All right, let's move on to number 3. All right, so we have 3/4 divided by 3/2. Hopefully the last problem gave you a little brain boost on how to work with these division of fractions problems. So go ahead and try this out, and we'll work it here together in just a second. All right, so much like we did last time, I've got 3/4 divided by 3/12. So I'm going to keep my first number the same. 3/4 remains the same. My division sign will change. Part of keep, change, flip. Division will change to multiplication, and we'll flip 3 over 12 to 12 over 3, or 12/3. So I have now 3/4 times 12/3. And then when we have multiplication in two fractions, we just multiply numerators across and denominators across. So 3 times 12 would be 36, and 4 times 3 would be 12. Now, I do have a number that with a numerator that's larger than my denominator, so I can go ahead and divide 36 by 12. If I were to do that, I happen to know in my head 36 is 12 times 3. So this would be, if we wanted to reduce that, we could divide them both by 12, and we would get 3 over 1, or just 3 as our answer. All right, if you have any questions on that, make sure you're checking in with the teacher today, because that is a process we've got to know moving on into the end of the year and ILEARN. That's a biggie for this year. All right, moving on. Find the quotient. Got a simple division problem here. This is long division. Remember, you've got 2 digits out front, so you're going to need to look at larger chunks of your dividend in order to find your quotient. So go ahead and give this a try, and we'll check it out here in just a second. Okay, so we've got 36 and 87. I'm going to go ahead and green for this one. All right, so 32. Well, I'm going to think of this as a 3, and I'm going to think of my 87 as something like a 1-digit number. So this is going to be between 8 and 9. Now, I know 3 can go into 9 3 times, but 87, this would be like 8.7 if we were thinking of it as ones and then tenths. That's a little bit smaller than 9, and 3.2 would be a little bit larger than 3. So I'm going to guess that this can go in exactly 2 times. Well, not exactly. It's going to be able to go in 2 times. Now you just multiply. 2 times 2 is 4, and 2 times 3 is 6. We just need to subtract and make sure that our answer here, our difference, is going to be less than 32. I think we're going to be okay. 7 minus 4 is 3, and 8 minus 6 is 2. We got 23, and that is less than, of course, 32. So we're okay on that. And now we're going to bring down our next digit. So we have 233. Again, we'll think of this as more like this being a tens digit, so something between 23 and 24. and this is a little over 3. So 3 would go into 24 exactly 8 times. But again, this is a little less, and this is a little bigger if we're thinking about that estimation. So instead of going 4 times, 8 times, that would be 8. I'm going to guess that it can go 7 times. Let's go ahead and try 7 and see how we do. 7 times 2 is 14. 4, carry our 1 over. And 7 times 3 is 21, plus 1 gives me 22. I think we're going to be less than 33 here. That looks pretty good. Actually, we're going to have to borrow in this case. That becomes a 2. And that 1. So 13 minus 4 is 9. And 2 minus 2 is 0. 2 minus 2 is 0. I'm going to leave those blank for me. You can put zeros in there if you need to, but Mr. Lambert gets a little confused if there are too many digits floating around. So I'm going to leave my 9 here. That is less than 32. I'm good to go. I'm going to drop my 6 down, and we're going to finish up here. So 32 into 96. Now, this one, this is a little bit over 3, but this is a little over 9. And I know 3, again, can go into 9 3 times. So let's try that 3 and see how this works. So 3 times 2 is actually, hey, 6. That's good. And 3 times 3 is 9. Awesome. We had an exact amount. So 96 minus 96 will give us 0 as a remainder. So our quotient here will be 273. Basic long division, but I know that is still difficult for some of you. Make sure you're hitting up extra math if division and multiplication facts are still a little tricky for you. That will help you out moving forward. All right, ladies and gents, and I believe this is our last one today. Greatest common factor. So it asks, what is the greatest common factor of, or GCF, of 18 and 27? And it says here, remember that a factor is an integer that is multiplied by another integer to get a certain product. Remember, integers are just fancy words for whole numbers. So we want 2 whole numbers that are multiplied together to get both of these 2 products. And now we're looking to find the biggest one that we have in common. And then it says use the rainbow method. So remember, you're going to write all your factors out, rainbow them together to see which ones go together, and then look for the biggest one for each of your integers. All right, go ahead and give that a try, and we will check the answer here in just a second. All right, guys, let's work this one together. So let's start with 18. Let's do this guy in blue. 18. So we need factors of 18. Well, I know 1 is a factor of 18. That's 1 times 18. I've got 2 times 9 can actually give me 18. And if I can do 9, then I bet I can do 3. Yep. Times 6 will give me 18. 4, there's nothing that I can multiply 4 by to get 18. 5 is not a multiple of 18, or a factor of 18, so we can forget that. Remember, we said 6 times 3 will equal 18. There are no 7s or 8s that we can multiply by to get to 18, but 9 times our 2 over here is 18. So that's a rainbow. Here's a rainbow. And remember, 1 was our next one, and we know that is 1 times 18. It's the next factor that's going to go with it. Can't be anything else in between. So here are our factors. We have 1, 2, 3, 6, 9, and 18. So we now need to check our factors for our other integer, which is 27. So 27. Well, let's see. I know 1 times anything will give me the number. So 1 times 27 is going to give me 27. I know those 2 guys go together. I know there's 27's not an even number, so I know 2 doesn't work. 3 actually does work. 3 times 9 will give me 27. 4 is also an even number, so we can't have those work. None of our even numbers are going to work here. 5 doesn't work. There's nothing times, because 5 times 5 is 25. 6 does not work actually. 7 does not work because 7 times 4 is 28, a little bit bigger than 27. 5, of course, doesn't work. 6 won't work because it's even. 7 times 3 is 21, but nothing we can get any closer to that. And then we are up to 8. There's nothing because 8 is even. Can't multiply that by anything to get to 27. And then we're to 9. So this is actually our full set here. We have 1 and 27 and 3 and 9. So not so many factors of 27. Now we just need to look for the largest factor that these two have in common. So we look 27 and 18. They are not in common, but look at our next set of factors. 9 and 9. That is the largest one that these two integers have in common. So our greatest common factor of 18 and 27 would be the number 9. That's our greatest common factor, or GCF. All right, ladies and gentlemen, that's it for today. Good job today. Good job powering through. If you have any questions on those, please make sure to talk to your teachers, because these are things that we need to know moving forward. All right, the next thing you're going to be doing for us today, you're actually going to be clicking on down and watching a video that's going to walk you through some directions on a short mini project. So you'll just have today to work on it, but it's kind of short. You'll be doing a little bit of research and then ordering some numbers, and then checking out how those numbers compare to each other, and checking out how their absolute values compare. All right, so we'll talk to you. Good luck on that, and we'll see you in just a moment.